So this is section 4.9, antiderivatives in calculus. And the definition of an antiderivative is on page 274. It says a function f is called an antiderivative of f on an interval I if f, this is called an antiderivative, should have wrote that down. Antiderivative if f, the derivative, f prime of x, equals f of x for all x on I. Okay? In other words, the antiderivative is taking the derivative and reversing it. So let me show you, let's try to remember derivative. Let's say that we have a function f of x equals 4x to the third plus 9x squared minus 3x plus 7, okay? If I found the derivative, do you remember how to find the derivative?
Yeah.
It would be, 12x to the third plus 18x.
Squared.
Oh, sorry, thank you. Can't read my writing. Minus 3, correct?
Mhm.
All right. Now, my question is how do we go from here to here? In other words, if I gave you this on a test, how will we go to here? Okay? Well, let's take a look at it. If, first of all, we know the answer, all right? So let's talk. This is the derivative, so what we're looking for is the original function, correct? Now, how would we do that? Take a look at this, and how do you go to that?
Half of
Okay, well, first of all, the x would go up
one.
1, so it would be 3, correct?
Mhm.
All right, good. All right. How do we get 4 from 12?
You divide by that exponent, right?
You would divide by that exponent, wouldn't you? All right, let's see if that works on the next one. So we went up 1, so it'd be squared, and then we would take 18 divided by that 2. Is that 9?
Yep.
Oh, well that's kind of interesting, isn't it? Are you following this?
Mhm.
All right, so then we would take the 3 and go up 1. What is the exponent of this x?
One.
It's 0, right?
Oh.
And so we would go up 1 and we would divide by
One.
1. But how would we know that that was a 7? We know it's a constant, but we don't know what it is, do we? So let's just put a c. So the original function would be 4x cubed if we did the division, plus 9x squared minus 3x plus c, wouldn't it?
Mhm.
That's pretty cool. Does it work on all of them? Yes, it does. So the definition of an antiderivative is to find the original function. That's why we write it like this. This is to find the original function. It is x to the n plus 1. Each one of these terms is x to the n plus 1, right? We added up 1 to it, didn't we? And then we divided by that n plus 1, and then we had to add a c to it, didn't we? And that's this c. All right, let's see if it works. Okay, let's say that I gave you the derivative, 5x to the fourth minus 3x squared plus 9x minus 2. Okay.
This is a new one?
Yep, this is a new one. But notice, Ava, that I gave you the derivative. So I want the antiderivative. In other words, I want f of x. All right? Okay?
3x squared?
Yeah. It'd just be f of x, right?
Mhm.
Okay, so what I would do is I would raise the x, I'd keep the 5, I'd raise the x up to 5, right? And then what do I do with that? I divide by the 5, that exponent, right, Ava?
Mhm.
Now the next one is I keep the 3 and I keep the x and I raise it up 1 and I divide by 3. Plus, now I'm going to raise the x up, right?
Yep.
Squared, and I'm going to divide by it. correct? And this 2 has an x, right? X to the 0, so we're gonna raise it up 1 and divide by it, right? But then we have to always add on that c, because we don't know if there's a constant or not. So one of the questions is what if there's no constant? Well, c could be 0, couldn't it?
Yeah.
Okay. So now if we simplify it, 5 divided by 5 is 1, so we have x to the 5th, minus 3 divided by 3 is x to the 3rd, plus 9/2 x squared, minus 2x plus c. Now you want to know what the interesting part is? Can you check your answer?
Yes.
Yeah, just take the derivative of that. The derivative of this would be x to the 5th, or excuse me, x to the 4th, 5x to the 4th, right? This one would be 3x squared. This would be 2 times 9/2 is 9x minus 2. Kind of cool, isn't it? All right? Okay, any questions on that? All right, so let's go through a few more problems that are a little bit more complicated than those. On page 276, they give the antiderivatives of cosine, sine, secant squared, and secant x tangent x. So I'm going to write those out. The antiderivative of the cosine x, the antiderivative, this is it, the antiderivative, put them right here, is sine of x. Okay? The sine of x, the antiderivative is a negative cosine of x. And secant squared x, the antiderivative is tangent x. And secant x tangent x, the antiderivative is secant x. You need to know these, okay? Especially these two. I use those a lot, okay? All right, so let's take a look, and let's say that this number 1, I would take the antiderivative, the derivative of g of x is 4 sine of x plus 2x to the 5th minus the square root of x all over x. Okay? So the goal is to find the antiderivative, or to find g of x. You understand that? Okay, what I'm going to do first, though, is I'm going to rewrite this so it's something that I can handle. The 4 sine of x is good, okay? But this needs to be separated. So I have 2x to the 5th over x minus x to the 1/2 over x. Notice that I changed it to different values, right? Okay, so I'm going to simplify this some more. So 4 sine of x plus 2x to the 4th minus. Now, what I want to do is when you divide, you subtract the exponents, right? So x, the 1/2 minus this 1 is x to the minus 1/2. You understand that, Ava?
Yeah, because 1/2 minus 1 is...
Right. So Grant, you get it? Okay. Now,
You would take the top, we have to take the top one, right?
well, it's always the top one minus the bottom one.
Yeah.
And if the top one is smaller than the bottom one, then we have
Negative.
negative, right?
Yeah.
Okay. So if I find the antiderivative now of this, so I have to label it different. Now we're finding g of x, correct? Okay. So now I'm going to take the antiderivative of sine of x. If I go up here, is a negative cosine of x, correct? So it's 4 times, I keep the 4, the negative cosine of x. All right, plus, I keep the 2, I raise the 4 up 1. So it becomes 5 and I divide by the 5, correct? Then I raise the negative 1/2 up 1. So it becomes a positive 1/2 over, and we divide by that 1/2. And then please don't forget the c. I've actually had some people that have forgotten the c on every single problem and missed every single one on the test. So don't forget that. So if I simplify this, I get a negative 4 cosine of x plus 2/5 x to the 5th. When you divide by 1/2, it's the same as multiplying the reciprocal. So it's the same as 2x to the 1/2. The reciprocal of 1/2 is 2 plus c. Now you can double check this. Since we started with a square root in the original, it might be best if we end with that square root. So it'd be plus 2/5 x to the 5th minus 2 times the square root of x plus c. Questions?
Wait, so where'd you get the 2 from? For the
This
x?
right here, I'm divided by 1/2 right here. Whenever you divide by 1/2, you multiply by the reciprocal. So, when if I'm dividing by 1/2, I'm going to multiply by 2. Does that make sense? You remember that? So when I multiply by 2, it's 2 over 1.
Okay.
Okay?
Because you're taking, wait,
You're
One.
dividing by 1/2.
okay. You're taking 1 divided by 1/2, right?
Yeah, because it's the
'Cause
one.
it's 1x,
Yeah, it's 1x.
not just, okay.
Okay? We good?
Just add right this.
All right.
Oh, you switched it to the
What time is it, Valerie?
minus, what is that, 2 square root x?
I have to have enough time to download this because I got to record the next class. Okay. So now let's take a look at example 2. It's actually example 3 on page 276. It says find f, which is the original function, if the derivative of f is x square root of x. And then it tells you something else. And f of 1 is 2. Okay, now the reason that they tell you this is so you can find an actual value of c
C.
for the first time. If they don't give this to you, you can't do it.
Okay.
Let's rewrite this as x times x to the 1/2. And if I multiply those, I add the exponents. Do you remember that?
Mm-hmm.
So I get x to the 3/2. Do you agree?
Yeah.
Okay. So now to find the original function, f of x, I would take the antiderivative of that. All right? Now, so the number in front is 1, so I leave it as 1, and I raise it up 1. If I raise it up 1, 3/2 plus 1, right? 3/2 plus 1 is 3/2 plus 2/2. If I get a common denominator, that is 5/2, and then I divide by the 5/2, right? Plus c. Did you understand that, Ava?
Not really.
Okay? I raise it up 1 and then I divide by it, right? So raising 3/2 up 1 is
Oh,
3/2 plus 2/2.
Oh, because you're plugging 1 in.
Okay? And so now I raise up 5/2 and then I divide by it. From this problem here, when you divide by 5/2, you're actually doing what, Ava? Multiplying by what? Which is 2/5. Okay? So what it looks like is this. 2/5, the x is to the 5/2, plus c. Does that make sense?
Yeah.
All right, this is the original function. However, I can find c because I know f of 1 equals 2. So what I'm going to do is if I put 1 in for x, I should get 2 back, right? So I'm going to put this 1 into this x, and I'm going to put this 2 in for the fancy way to write y. So I'm going to put 2 equals, coming up here, 2 equals 2 times 1 to the 5/2 power over 5 plus c. Now look here, guys. 1 to any power is
1.
1. So I get 2 equals 2/5 plus c. So to find c, I'm going to subtract 2/5 from both sides, right? Not going to show that because I'm running out of room. So I want 2 minus 2/5 equals C. Well, 2 is 10/5, isn't it? And if I subtract 2/5, that gives me C is equal to what? C equals 8/5, doesn't it?
Yeah.
Now I put it back in, this I put back in to here, right? So I have f of x equals 2x to the 5/2 power over 5 plus 8/5. Now, since they have the same denominator, I can put them together or I can leave them apart. It does not matter. It's up to you. Questions about that? Ava?
No.
Okay.
Yes.
Go. Yep.
When you took 2 times 2/5, what's that say?
See this? Okay, this is 2 minus
Oh.
2/5 because I'm subtracting it from both sides, right?
Okay.
Right? And
Yeah.
so that would be 10/5 minus 2/5, and that's how I got the 8/5. I got a common denominator, correct?
Mhm.
Okay. Questions? We good? Ava?
Yep.
You sure?
Mhm.
All right, let's move on. So the last problem I'm going to do is I'm going to do this twice. Okay, this is example 3. It's actually example 4 in your book. It says find f if f double prime of x equals 12x squared plus 6x minus 4. And then it says f of 0 equals 4 and f of 1 equals 1. Now you're going to have to do one of these on the test. So it's important that we go over it. So some key things before we start. You have a double derivative being this, and you have this and this. You have 2. So we want to find the constants. And this is what I mean by this. Let's start by finding just the derivative. When you have a double derivative, when you do the antiderivative, you get just the derivative. Let me say that again. When you have a double derivative, when you do the antiderivative, you get just the derivative, or the to the derivative. Blah, blah, blah.
Yeah, the derivative.
Sorry. All right. So I'm going to take the antiderivative of this. So I'm going to take 12x. I'm going to raise it up and divide by it. Plus 6x. I'm going to raise it up and divide by it. Minus 4. I'm going to raise up. Can I just put 4x and you guys understand why?
Yeah.
Okay. Plus c. Do we agree?
Yes.
Okay. And so I get 4x to the third plus 3x squared minus 4x plus c. Correct?
Mhm.
All right. Now I'm going to find the original function, which is actually taking the antiderivative of the derivative. Right?
Mhm.
So once again, I'm going to raise it up. 4x to the fourth divided by 4 plus 3x cubed divided by 3 minus 4x squared divided by 2 plus cx, right? You see where the x come from on the c? Because I had it's x to the 0, so I had to raise it up and divide by 1, correct? But now I add a new constant. I don't want it to be c, so I'll call it d. Now let's simplify this. 1x to the fourth plus 1x to the cubed minus 2x squared plus cx plus d. All right? We got it? That's the original. Does that make sense to you? Okay, so we want to find out what c and d are, right?
Yeah.
Let's go up here, and the first thing I notice is that f of 0 is 4. So if I put 0 in for all the x's, I get 4. It's very crucial that you put this one in first. Why? Because this goes to 0, this goes to 0, this goes to 0, this goes to 0, and I have d left. And then I can solve for d. All right? What's that? Okay, so if I put 4 in for this, and I put 0 to the fourth plus 0 cubed minus 2 times 0 squared plus
So it's
c
0
times
equals?
0 plus d. What? I'm-
So it's 4 equals, and then you put 0 into there.
I'm gonna put 0 into all the x's. I'm gonna use that point first. Correct?
Mhm.
So what I get is 4 equals
B.
D. That's awesome. Now I can go back to this one again. And I now know what D is. And so I can use this point.
Oh my goodness.
Alright, I can use this point. I can put 1 in for f of x. I can put 1 in for the x to the 4th. Plus 1 into the x cubed. Minus 2
Are you
times.
using a double derivative or which one?
I'm using the function. This one right here.
Okay.
Right here. And I'm putting 1 in for all the x's. And I'm going to get 1 for the answer. So I put 1, this one, Ava, right here.
Mhm.
This one goes
Yeah.
into the f of x,
Just the regular.
regular one, right? And then I put c times 1. And then what's d?
1 or 4.
4. And so I plug it all in like that. And so what I get is 1 equals 1 plus 1 minus 2 plus c plus 4. So if I do the math, I get 1 plus 1 is 2. 2 minus 2 is 0. And so I have c plus 4 equals 1. If I subtract 4 from both sides, I get c equals a negative 3. Alright, so now I know d, and now I know c. So I can put them both back into the original.
Wait, you got C equals what?
Negative 3. Is that what you got?
Yes.
Okay. So I have f of x equals x to the 4th plus x to the 3rd minus 2x squared plus, remember that c is a negative 3 and negative 3x plus 4.
I was just 4 minus 1. 1 minus a negative 4?
It would be negative 3. 1 minus 4.
Then you have to, oh yeah. I don't remember that.
Ooh, what's going on?
I don't remember that. I thought when you put the 4.
Okay. I'm going to write the assignment because my computer's messing up. 1 through 15, 19 through 34. What's going on?